Okay, so before we start the tutorial activities, I heard that some people are having problems with the first question on problem set B. I think it's 2.5.1. So to help you guys with that question, I prepared a really similar question, and I plan to cover that question first before we move on to tutorial activities. So let's do this question. It should give you a brief idea of how to approach 2.5.1 because they are quite similar. So let A be the set xy in natural square such that x plus y equals to 3. And let B be the set that has 2 points, 1, 2, and 2, 1 in there. Okay, shut up. Go. Right, and I want you to prove that A equals to B. I think this question is quite similar to your problem set question. So let's try this out. So our first step is that since we want to show two sets are equal, you need to prove that A is a subset of B, and then you need to prove B is a subset of A. To show a set is a subset of another set, you need to show that if you pick any arbitrary element x in A, this is going to imply that x is also in B. If you can show this, then that means A is a subset of B. What are we working on right now? We are working on this question. I created this question so that it can help you with 2.5.1 because I heard some students are having trouble proving that question. So let me write it down. This is similar. This is from nowhere. Okay, I don't think you can find it anywhere. So this is from nowhere. I made it so that it helps you with 2.5.1, which is from your problem set. Okay. Now let's prove this. First of all, I want to prove A is a subset of B. So let's prove this direction. Again, our first step is pick an arbitrary element from A. So let's do that. So let xy be an element of A. Why did I pick xy instead of x? Because all the elements in A are in this form, okay? Now, since xy is in A, that means xy satisfy everything in this. In other words, my x is a natural number, my y is a natural number as well, and we know that x plus y equals to 3. Now, notice that our x is strictly less than x plus y. Why is that? Because our x and our y are natural number, which means they are both positive. So x is strictly less than x plus y because y cannot be 0, so they cannot be equal, which equals to 3. This means our x is less than 3. And we also know that x is a natural number, which means x is either 1 or 2. Okay? Again, how did I get this? First of all, I know x and y are both natural number. So I know x is strictly less than x plus y, and I know x plus y equals to 3. Alright, which means x is strictly less than 3, and we know it's natural number, so it can either be 1 or 2. Similarly, we have y is strictly less than x plus y equals to 3, which means y can either be 1 or 2 as well. In other words, our xy can have the following possibilities. We might have 1, 1. That's when x is equals to 1, y equals to 1. We might have 1, 2. We might have 2, 1. And we might have 2, 2. But, again, remember our xy is from A, so xy has to be from this set, intersect the set A. Okay? So intersect the set A, which means x plus y has to be equal to 3. So that's gonna help us to get rid of 1, 1 and 2, 2. Okay, because 1 plus 1 equals 2, 2 plus 2 equals to 4, which means they cannot be x, y. So this implies that x, y can only be 1, 2 or 2, 1, which is our set B. Okay, this means that A is a subset of B. Does this part make sense? Any questions so far? Doesn't this show that A equals to B? No, it doesn't show A equals to B. This only shows that A is a subset of B. Now we need to show B is also a subset of A to claim that they're equal, okay? When you prove two sets are equal, you have to show they are subsets of each other. We don't accept any other answer. Any other question? Can I move on to the next direction? Okay. So our next direction, I want to show B is a subset of A. To show that, again, we pick an arbitrary element from B. So let xy be an element of B. And here is our set B. If xy is an element of B, which means xy can either be 1, 2 or 2, 1. So let's write that down. This means that xy equals to 1, 2, or xy equals to 2, 1. All right? In either case, if we add x and y together, we have 1 plus 2, which equals to 2 plus 1, which equals to 3. So our 1 plus 2, we get it from here. Okay, add x and y together. 1 is our x, 2 is our y, and 2 plus 1 comes from here. All right. Also, we know that both 1 and 2 are natural number. Okay, why do we need to say that? Because for set A, we have two conditions. The first condition is x and y are both natural number. And the second condition is if you add them together, you get 3. So we need to check both conditions. Since both are true, therefore, our xy is also an element of A. Alright, since we started with this and eventually we get this, that means B is a subset of A. And therefore, A equals to B. That's the end of the proof. Any question? Why is there a square unnatural number n? Good question. So let's talk about it. What's n squared? N squared is the same as n Cartesian product n. What does this mean? This means that you have points, let's say x, y, in n Cartesian product n. This means that x is a natural number and y is a natural number as well. So it's just like a notation. Similarly, you can have z square, r square, such things, which means both of your x and y are from real number or natural number or something like that. So if we have y is a real number while x is a natural number, then you would say xy is in natural Cartesian product real. Does that make sense? Okay, cool. Any other question? Question in an R. So to answer your question, if you wanna say x is in natural, y is in real, then you should say, let me pick another color so I don't confuse you. Let's write it here. Okay, so you can say x, y is in natural Cartesian product real. If you write it in this way, that means x is a natural number and y is a real number. Make sense? Okay, any other question? Wait, okay. You copy down. You can take a screenshot or I'm gonna post a recording later anyway, so if there are two numbers separated by a comma, we can add them together in a set. What do you mean add them together? Like x, y, or 2, 1 equals to 2 plus 1. No, you cannot do that The reason that we're adding them together here, I suppose you are talking about this part. The reason that we're adding them together is we want to show this is true, okay? For any element in B, x plus y equals to 3. Okay, if we have 3 variables that are natural numbers, would that be written as n to the power of 3? Yes. Exactly. So some people might think n squared means that every number you have has to be a square number, such as 2, 4, 9-ish, but it's not that. That's not the case, okay? Because we're talking about Cartesian product here. Any other question?
Yeah, I have a question.
Okay, last question.
So we can just prove that B is a subset of A by proving that all of the elements of B can be x plus y equals 3, right?
No question?
Hello? Can you hear me?
Cool. Let's move on. So let's do the tutorial. Oh, set A is. Oh, okay. Let's go back.
Hi, can you hear me?
Set A. You mean my volume's off? Yeah, I can hear you. Let me turn it back on. Did anyone say something? If you said something before, say it again.
Hi, can you hear me now?
Yeah, I can hear you now.
Yeah, so you just proved that B is a subset of A by proving that all elements of B can satisfy x plus y equals 3, right?
Yeah.
So if, for example, B has a lot of elements in it, like how do I have to prove that one by one, or what?
You okay? If there are ways to show them generally that's true, then go ahead. If there's no way to do that, then you might need to do them one by one. You know what I mean?
Oh, okay. Okay.
So if you can come up with a smart way to do that, then go ahead. All right. Someone asked a question before. Let's see. Set A is a set full of sets of x and y, right? So set A is it's in the n-squared plane. So let me draw it out. So let's draw it here. Basically, set A, it's saying that we have natural and natural here. So they're saying that we have like dots in this plane. For example, 1, 1. Like here, that's 1, 1. 2, 1, like this. So those are dots in the plane. Set 1 is saying that, oh, we have xy in this, which means we have dots in this plane, right? And then they're restricting the condition by saying that, oh, your x and y has to be equals to 3. So eventually you just get 1, 2, and 2, 1. So 1, 2, and 2, 1. So eventually it's just those two dots here. But this condition means that you have points on this n-squared plane. Is a set or just a number pair? XY is just a number pair, it's not a set. In this case, it's not a set. But sometimes it can be a set. For example, when you use it to represent intervals, then its intervals are sets as well. Yes, that would be a set. So if you write this, that's a set with two elements in there. So this and this, they are not the same. Okay? Any other question? You can't? You can't see the writing. Oh, that's interesting. No, I think it's not connecting well. Let me stop and reconnect. Come on, come on, come on, come on, work. Okay, can you see it now? I wrote in purple here and here, here and here. Okay, cool, nice. Let's move on then. Okay, so the problem is those two are not the same thing, okay? Learning objectives. By the end of this tutorial, you guys should be able to identify if an inequality is true or false and prove inequalities using or similar to triangle inequality. Number 2, apply set operations to given sets, union, intersection, complement, set difference. 3, sketch subsets of R and R square. So we talked about R square, okay? So this means R Cartesian product R. Alright. Number 4, prove equality of sets by definition unwinding and double inclusion. Let's just go straight into the activities. Activity 1, which of these statements is true for all x, y greater than or equal to 0? I'll give you 2 minutes to think about them and then I'll take them up. You don't know anything? Explain this. What does this mean? What does which part mean? Which part, specifically which part do you not understand? Sorry. If you guys wanna talk, then say it in the chat, cause I wanna turn off my volume cause I keep getting notifications. Okay, anyone finished activity 1? Part 1? Yes? Okay, so which of the statements do you think are true? True, false, true. Okay, that's correct. Okay, someone tell me why is the first one true? How do I prove it? This is true. If you think a statement is true, then you need to prove it. If you think it's false, then you need to give me a counterexample. So for the first one, if you think it's true, why is it true? What proof can you give to me? Anyone? Okay. Okay, so no one said anything. I guess I'll do it myself then. This is true because we're given x is greater than 0. Alright, because we're given x is greater than 0, which means since x is greater than or equal to 0, that means the absolute value of x equals to x. Also, x plus 4 would also be greater than or equal to 0, which makes the absolute value of x plus 4 equals to x plus 4 itself, and we know that x equals to the absolute value of x, which makes it equal to the absolute value of x plus 4. Okay, so that's a really short proof. Number 2, it is false. Can someone give me a counterexample? So what's my x and what's my y to make it false? Okay, you guys gave me a lot of examples. Let's pick the first one. Let x equals to 3, y equals to 1. Yeah, 1. Then we have 3 minus 1 is less than or equal to 3 minus 3 times the absolute value of 1. So that's going to give us 2 is less than or equal to 3 minus 3, which is 0. This is false. Okay? Number 3. Anyone know how to prove it?
I think I know.
Anyone? True. False.
No?
True. Proof, I proved it using 2 different ways. The first one, you can square both sides. And the second one, you can discuss cases. 2 different methods, okay? Can you hear me? I cannot hear you. Okay,
Oh?
let me unmute myself. Now I can hear you. Okay,
Okay, so since we know that x and y is always greater than equal to 0, then we can eliminate the absolute value on the left side, right?
we can. Oh, yeah. It's actually easier than I thought because I ignore the part that they are greater than or equal to 0. Yeah. You can. Yeah, basically you can get rid of this already. So this will give you x plus y
So
greater
yeah,
than or equal to this. Yeah, you're right.
of x minus y, right?
Yeah.
We can get the inside the absolute value of x and absolute value of y too, right?
Yeah, so that's gonna be this. You're right. And then Yeah, it cannot be negative. I actually ignored the condition here. So what I wrote here is for when x and y are real numbers. Yeah. Why can you remove the absolute values again on the right? You don't know if x is greater than y though.
Yeah.
Anyone know? Think about triangle inequality. Guys, think about triangle inequality. Think about triangle inequality.
Okay, so by triangle inequality, that means that x plus y.
Okay, it's right here. By triangle inequality, that will give you this is less than or equal to this. Okay? Which equals to this. And we know both are greater than or equal to 0, so that's going to give you x plus y. So eventually you get this is less than or equal to this, which is the same as this. Does that make sense?
Yeah. Can you also discuss that when x and y is all real number? Because I don't understand if x and y is all real numbers.
X and y are what?
Can you discuss when x and y is all
All
real
real
numbers?
numbers? Oh, yeah, I was going to say that. The proof of this when x, okay, let me write it down, just in case someone don't catch it. The proof of 3 is in video MAT102 something something something. I don't remember the title is, but it ends with block 6. Okay, you can find the link in the Quarkus page as well, my Quarkus page. So the proof of this, where x and y are all real numbers, is in this video. I proved it using 2 different ways. Are we cool? Okay, let's just move on. The proof is really similar to part 2 though. So once I did part 2, you should be able to prove part number 3 as well. So let's do part 2. Part 2 is when x and y are real numbers. This is more interesting. And we need to prove this inequality. What do I do next? What do we do first? Anyone know? Anyone? What do I do first? Square both sides. Exactly. So we take square both sides. We get. Let me just write it down first. Why can we square both sides? Square both sides, we'll get this. We can square both sides because we know both sides are greater than or equal to 0. So you don't need to flip the signs or anything. Open a bracket. This will give you plus absolute value of y squared minus 2 times absolute value of x times absolute value of y is less than or equal to x squared plus y squared minus 2xy. Now, as you can see, This and this, they are the same thing. This and this, they are the same thing as well. Which means what's left is negative 2 absolute value of x times absolute value of y is less than or equal to negative 2 times x of xy. Alright, now you can see both sides we have negative 2, so you can divide by negative 2. But negative 2 is a negative number, which means this is going to change. So eventually that's going to give us absolute value of x times absolute value of y is greater than or equal to xy, which is true by I don't know which basic fact it is. Okay, that's it. That's a proof. Any question? Wait, okay. How do we prove the last line? How do we prove the last line? I just said it's true by basic fact. Yes, it is a basic fact. I don't know which one it is, but it's this. As less than or equal to this. So we have this, we have this. Now can we move on? How can we jump? Okay. So suppose x and y are both positive or both negative, then you can multiply them together without changing the sign. Suppose one of them is negative, so that's a negative number, which is going to be always less than or equal to a positive number. So it's true, but basic fact. Yeah, you can do that as well. This will give you this. Oh. So, in other words, xy is less than or equal to xy, which equals to xy. You used this basic fact, but instead of x, you put xy in there. Any other question? Few things I want to emphasize. First, if you want to write it in this way, you need to put if and only if here, like what I did here. Otherwise, it's just rough work. The other way to make it a formal proof is starting from this step and go back. Okay, so you can either add if and only if, or you write it backwards. Okay, any other question? Question? Yes, no? Okay, I suppose no question, so let's move on. Activity 2, I need you to find the union of those two sets. I'll give you 1 minute to think about it and we'll take it out together. Oh, we only have 10 minutes left. Okay, since we only have 10 minutes left, let's do it together. What's this set? What's this gonna give me? I mean everything in the bracket, okay? I mean everything in the bracket. What's that gonna give me? Anyone? Okay. Be careful though, for people who wrote down your answer, you should put it in the set, okay? Because this is a set. So this is gonna give you -1, 0, 1, 2, 3, 4, 5. Not include 6. What about this set? If you list the elements out, what is this gonna give you? Z means integers. What does this gonna give you? Anyone? Yes, if this is this bracket, then it will include 6. But it's round bracket, so it does not include 6. Yeah, you're right. From 0 to 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if you take the union of those two, that's gonna give you from -1 to 10. Okay? Number 2, they want you to sketch the following subsets of our Cartesian product R. And our A is the interval 0 or -1 to 1. Our B is the set, and they want you to sketch a Cartesian product A minus B. So what I want to do is I want to start with a Cartesian product A. So let's sketch it here. Actually, let me use this instead. Let me make my own life easier by using this perfect. This is perfect. Okay. So let's draw it here. This is R. This is R as well. My A is from -1 to 1. So suppose this is 1. Then that's -1. This -1. And that's 1. Alright. So our A is everything between -1 to 1. So it's the red part. Okay, this is A. This is A. And then, since we want a Cartesian product A, so we need to draw another A on the vertical real line. So that's gonna be here and here, and it's everything in between there. So eventually, our A Cartesian product A would be everything in this square. So make it clear. Alright, so A Cartesian product A is gonna be this part. Okay, let me make it thicker so that everyone can see. Alright, and everything inside this square, so all the red part is our A Cartesian product A. That's perfect. All right, including those two corners, okay? Including those those four corners, because we can reach there as well. This is our A Cartesian product A. Any question? Oh, any question, guys? Nope. Okay, so this is clear. Now let's look at B. Let me use another color instead. B, we have this set. If you look at B, you'll see that it looks kind of familiar, and I would say this reminds me of this. Does everyone know what this means? What is this equation for? Circle. Okay, it's not a function, it's an equation of circle. So that's a unit circle, exactly. A unit circle with origin 0, 0, a center at origin and radius 1. So let's draw it out. That's gonna be my unit circle. Hopefully it's perfect. There we go, that's perfect. Now, I draw out this. But what we need is this. So which part exactly is our x squared plus y squared is negative, no, not negative, is less than or equal to 1? The entire area of the circle. So are we talking about inside of the circle or outside of the circle? Inside and including the circumference. Yes, exactly. So we're talking about inside of the circle, including the circle itself. So we're talking about everything inside, okay, since it's less than or equal to 1. So our green part is our B. This is our B. Now they want you to sketch this, which means we want the red part, but not the green part. So let's copy this part and do it again. Oops. Right, let's make it here. And now tell me which part exactly is our A cross A minus B. Which part exactly is my A Cartesian product? Box remove circle. So the area in the square that's not in the circle. Exactly. Okay, so we want everything that's inside of the square but outside of the circle. So I'm gonna use another color. Let's use blue. So we want this part. Now my question is, do we want the square itself? We want the square itself. Okay, so let me draw it out. We want the square itself. What about the circle? Do we want the circle or not? No, we don't want the circle. So if you don't want something, you make it dashed line, okay? That means you don't want this part. All right. So we want, do I think? All right. So we want the square, we don't want the circle. What about those four intersection points? Do we want them? The intersection points? No. If we don't want them, what do we do? Difference. That's difference. That's like minus. This set operation, this means minus. It's the same as this. So we don't want the intersection points. If you don't want them, you use the empty circle. So let's use this to represent that we don't want those. We don't want those points. Gonna erase what's inside there. So we don't want those dots. All right, and what's left here is our A Cartesian product A minus B. Open circle, yeah, you use open circle to represent that you don't want that dot. You don't want that point. Okay, is this clear? Yeah, I think it looks beautiful too. I hope this is clear. Because we're running out of time. It's 6:02 already, and we have one more activity. Is it impossible to divide two sets? No, you cannot do that. You cannot divide sets. Okay. Move on? Can we move on? Yeah, okay. Last activity. You guys are free to leave now, but if you wanna stay, I will cover the rest of the activity, okay? It's being recorded, so even if you leave, you can still watch the recording. But we'll move on to the last activity. So part 1, if A union B equals to A intercept B, then which of the following is not true? I'll give you 1 minute to think about it, and then we'll take it up. Four? Yeah, you're right. 4 is not true. Why is it not true? First of all, what does this tell us? What does this tell us? What can we conclude from this? A equals to B, exactly. Okay, so this tells us A equals to B. Then A minus B is gonna definitely give us the empty set, but this one, it's not definitely the empty set. Okay, unless A equals to B equals to the empty set. Otherwise, it's not empty, so it's false. Okay, yeah, A and B are the same sets. All right, that was fast. The last part, proof for all sets A, B, A minus A intercept B equals to A minus B. Yes, if A and B are both the empty sets, then 4 will be true. But now we're talking about the general case, right? So if we have one counterexample, then it's not true. Alright, let's prove the second part. Again, you need to prove two sets are equal, so you need to show this set is a subset of the set and the other way around as well. Alright, so our first step is to pick an arbitrary element in the first set. Alright, this is gonna give us x is in A and x is not in A intercept B. Do we have any question about this? I hope this is clear. Because in my last tutorial, a lot of people asked why. Anyone here do not understand this step? Okay, I see no question. All good. Okay, cool. Now, what I want to say is side notes here about this, because this is where people make mistakes. Suppose I'm giving you x is in A intercept B. What does this mean? Arbitrary element means you pick any random element. So you randomly pick an element. Can you explain it? Okay, I'll explain it. We let x be in the set A minus A intercept B. Means x, well, x is definitely in A. Do you agree with that part? Yes, okay. A minus A intercept B. Remember when we draw this? We have something minus something. Minus means that you don't want this part. Just like what we did before. We don't want the green part. Same here. We don't want this part, which means x cannot be in this. Does that make sense? No? You? That's how I get from the first line to the second line. Because we don't want it to be in A intercept B. We want to take that part out. That's why it's minus. Okay? So back to here. If I give you x is an element of A intercept B, what does that mean? Guys, what does that mean? X is in A and X is in B. Okay? And, okay, this is really important. And now, my point is, if we want to take the opposite of that, before we want X is in this. Now we don't want it to be in this. So I want to take the opposite of this. When you change your second line, you need to take the opposite of the first, the opposite of and, which will give you or, and here as well. Okay? Which means x is not an element of A intercept B, means x is not in A or x is not in B. So let's write it down. X is not in A or x is not in B. now you can just use a distribution law, distribute them out. So distribute this with this and then this with that as well. So that's gonna give you x is in A and x is not in A. They're together. Or x is in A and x is not in B. Alright, so basically I just use distribution law. Then my next step, if you look at this, what does this give us? I'm saying x is in A and x is not in A. What does that mean? Nothing. Exactly. That means the statement is false. Exactly. Now, what you're doing, yeah, or you can say it's the empty set. Now, if you're picking from this or this, which one do you pick? The second. Okay? So this is gonna give you x is in A and x is not in B. And that's gonna give you x is in A minus B. Alright? After you get this, that means we finished the forward direction already. So we finished this direction. Any question? 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 Nope. Okay, cool. The other direction, you start from here. You pick an arbitrary element x from A minus B. That's gonna give you x is in A and x is not in B. So that's if and only if. Then you have this statement. You can add a empty set or you can add a false statement because you have or statement. Since it's or, okay? So this direction can go back as well. Now, once you get here, you both have x's in A, so you take them out. Just like here, you distribute them and you take them back. So that's reversible as well. And then from here, you can get back to that as well because they are the same thing. Okay? Because they are the same thing. So, and from here, you can go back as well. Therefore, they are equal. Because the backward direction is exactly the same, but backwards. And that's the end of the proof. Alright, any question? Are we good? Cool. Okay, so this is the end of the tutorial. We have some extra practice here, so when you're free, try to do them. The more practice you do, the better you get, I would say. The recording will be uploaded very soon, so if you missed anything, you can watch the recording again. The practice questions, the extra practice questions, I will make videos about them sometime this week before your problem set B due. I don't know if they are going to be helpful for your problem set B because I haven't checked yet, but I will make sure I upload them before the due date of your problem set B. So if they could be helpful, I don't want them to be useless. Anyway, that's it. Have a good weekend. When is it due? I have no idea. I think it's sometime on the weekend. Is there a decent online proof course somewhere? Proofs, but I want more practice. If you want more practice, you can Okay, a lot of questions. Let's answer each one. Okay, so problem set B is due this Saturday. I don't know what time, but I know it's due on Saturday. Is there a decent online proof courses somewhere? I have no idea. If you want more practice, you can practice the questions from your textbook. They are really good questions. Or if you even want more, you can check my YouTube channel where there's Google Drive link. You can check that. That has all my tutorial worksheets from previous years. If you're too lazy to do that, you can. Okay, let's show you this. If you're too lazy to do that, you can go to Quarkus. You can click 102 and you go down, 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 go down. There we go. Tutorial 0901/0906 with Lean. Click week 2 and you can see that here we have other resources. You have other resources and I posted my tutorial worksheets from 2020 winter. Okay, so you can practice on those questions as well. I did question once a day. All right, so you can practice those as well. The solution is posted here. Okay, so you can check those. All right. And if you don't understand any concepts, I have videos cover that as well. And yeah, we don't have approved textbooks, do we? Your textbook is a course notes written by shy folks. All right, any other question?
Hello. Can you hear
Hello.
me?
Yeah,
Question, if you don't mind.
yeah, go ahead.
I don't understand the difference between a subset and an element. So if like
Oh, okay, that's okay. We can go over that. That's a common question. Actually, it's okay to ask. I'm happy that you asked. All right, let's do it somewhere. I need to find a blank space. Let's do it. Huh.
I
Okay.
was wondering, for example, X is a subset of Y. Does that mean X is also an element of Y?
No,
And-
no.
oh,
Okay, here we go. Um, Element means, let's say we have a set A. Wait, why can't I write it? Interesting. Oops. Oh, okay. Delete. Okay, right now, let's say we have a set A, which has some element in there. Let's say 1, 2, 3, and I want to add something unusual. Let's add the set of 4, and let's say this is my set A. Okay, how do you determine what's subset, what's element? Elements are those. So you see between each, if the element of A is like something that's being listed in the set. So for example, 1 is an element of A. 2 is an element of A as well. 3 is an element of A as well. And the set that has 4 inside is an element of A as well. Okay, does that make sense?
yeah.
Yeah, okay. So that's element. But my question is, what about the set of 1? Is this an element of A? Yes or no?
No,
No, why is that?
because A doesn't have a set that contains one.
Okay, because well, this is not, it's not written in here, right? It's not listed in this. So it's
Yeah.
not an element. It's a subset of A because this is a set and it has one element in there, which is 1. By definition of subset, it means that if A is, let's say, I'm claiming that this is a subset of A. Why is that? Because the only element this set has, which is 1, is also an element of A. Okay? So this set, the element of this set is also the element of A. That makes it the subset of A. Does that make sense?
Yeah.
So in other words, we could have something like 1, 2, 3. That's a subset of A as well. Okay? We know that this is an element of A, but it's not a subset of A. But if you round a subset, that's gonna be the set that has this element. This would be a subset of A.
Wait. What?
Okay,
Wait.
okay. Because this set has one element in there, which is this.
Yeah.
You agree?
Eminent
And
element
this
is.
element is also an element of A, which makes this set a subset of A. Does that make sense?
I think. So if wait. Hmm.
This set has one element, which is this. And we know this element is also an element of A.
Yeah,
Therefore,
yeah.
this set is a subset of A. Make sense?
The subset of every set, right?
It's for the same reason that R is not a subset of, yeah, exactly. So in your case, Andre, in your case, R would be an element of the set that has R in there, but not subset. Okay,
Okay,
and
so
yeah,
I have another question. So like we know that an empty set is a subset of every other set, right?
yeah.
So
Do you know why?
I don't know.
Okay,
And
so recall the definition of subset. Okay, think about the definition. The definition is saying that if A is a subset of B, then every single element in A is also an element in B.
yeah, that's
Okay,
right.
so that's a definition. The empty set has no element in there. Okay, it's empty. It has nothing in there. So that's gonna be an element of the other set because it's nothing, right? No element. That's why it's the subset of all sets. But it's not necessarily an element of all sets unless you put the empty set in a set.
Wait, can you repeat that last one again?
Okay. Let me write it down.
Wait,
So,
so if
oh, okay, this is killing me. The empty set is a subset of all sets, but it might not be an element of certain sets. One cannot be an element of set. For example, if you have a set, let's say B, equals to the set, let's say 2, 5, and then I put the empty set here. Okay, in this case, the empty set is the element of B.
Yes.
But if my B don't have this part, let's say I delete this part, okay, take this out, then the empty set is not an element of B. For example, our A here, it doesn't have empty set as element. Does that make sense?
It makes sense.
Okay.
So like, for example, we know that an empty set is a subset of all rational numbers, right? But that doesn't mean that empty set is an element of all rational numbers, right?
Wait, repeat that again?
So an empty set is a subset of rational numbers,
Yeah,
right? But
yeah,
an empty set is not an element of the rational numbers
right.
because in the natural in the rational numbers there isn't a set containing empty set, right?
Yes, because the set of rational numbers, those are rational numbers. There is no element there is no the element empty set. You didn't put the empty set in there, right?
Yeah.
Yeah,
Oh, okay, okay. I understand now. Thanks a lot.
no problem. Okay, I think that's it. I'm gonna end this and have a wonderful night.
Sorry, could I
Yeah,
just confirm something? I don't know if my voice is weird today. But through set equality, if we say that if we're looking for the subsets of A, would that mean that the entirety of A would be technically a subset?
yes. The
Okay.
A is also the subset of A. Yeah.
Okay, so that's fine then.
Mm-hmm.
Okay, perfect. Thank you so much.
No problem. Right. Bye, everyone.